All right, everybody, we are doing, let's see if I can get a pen here. Okay, so we are working on our lesson for homework first and total count problems, and put at the top of the page. Everybody knows how to do that. Now, we went over these in class, so I'm going to show these for just a few seconds. You can always pause and come back and look at these. Okay, there's the last one. And if you need to see any of those, just pause your video and go back and look at them. Okay, now these are the ones that we did as part of the quiz that we took. So now I'm just going to go over them with you. 22 divided by 4 is the same thing as 11. Divide the top by 2 and the bottom by 2. And 11 halves is 5 and 1/2. Which you could also write as 5.5 as a decimal. Okay, so 11 divided by 2 is 5.5. On the next one, we have 11 minus 12 is 48. So we're going to add a 12 to both sides. And when we add those together, we're going to get x. This one's going to cancel. And 48 plus 12 is 60. So x is 60. On this one, we're to find the temperature. The temperature is going right here. Now remember, it takes 1, 2, 3, 4, 5 steps to get from 20 to 30. So each one of those steps is 2 degrees. So 2 degrees, 4 degrees on top of 20 is 24 degrees. And okay, so Mei Ling walked 100 yards in 1 minute. How many feet per minute is that? Okay, so let's 100 yards in 1 minute. Okay, so let's use our conversion factors. Let's multiply. Now, I want yards on the bottom because I will want yards to cancel. And I'm wanting feet per minute. So I'm going to say how many feet is in a yard. So 3 feet is 1 yard. So now my yards will cancel yards. And 100 times 3 feet is 300 feet per 1 minute. And the answer is 300 feet per minute. Okay, write 5 billion in scientific notation. Well, 5 billion, remember, million has 6 zeros. So 5 billion, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, that's billion, right? So this is the thousands, millions, billions place. So 5 billion. And now when we're changing this to our scientific notation, our decimal is going to move right here, right after the first non-zero number. So we're moving 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So it's going to be 5 times 10 to the 9. Okay, now 5.0 times 10 to the 9 is correct also. Sometimes we just don't write that 0. Both of those would be considered correct. 2 sides of a triangle are 7 and 9. The third side must be between what 2 numbers? Now, you guys were trying to get this out of Miss A in the class, but let's think about it. So let's put a side here, and we're going to make this one 9. and we're going to make a side here, and we're going to make this one 7. And we're trying to figure out what are the limits on this third side here. Okay, now remember that a triangle must have some height. But let's just pretend that this line right here went lower and lower and lower and lower and lower and lower and lower. Okay, so finally it would just lay right down here on top of this one. So what we're saying is that this angle right here goes almost to 0. Okay, so close to 0 that we almost can't see how far it is off. So wouldn't this 7 come lay down on the 9, and then this leftover little bit here would be 2. So basically what I'm saying is you would have 2, you would have 7, 9, and if this was very, very tiny angle, this one would be a little bit less than 2, maybe 1.9. Okay, so it would have to be greater than 2. Excuse me, 2.1. It has to be greater than 2, because if it was less than 2, it would not meet this other one. Okay, it has to be greater than 2. My bad. All right, so this third side has got to be greater than 2, so we'll put less than x. We'll put this as x right here. But suppose that, we'll get another color. This angle gets really, 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 really big. Okay, so it's not quite 180, but oh man, it's really wide. Okay, so this angle, and so now this is 9, and this one right here is 7. And if it was laying down flat, then you would have 9 plus 7 is 16. But it can't lay down exactly flat, because it's got to have some height to it so that you can connect these two sides and make it a triangle. So it has to be less than 16. So 2 is less than x is less than 16. Those were the two numbers. So basically, you subtract these two to get the first one. You add these two to get the last one. Okay, so now we're working on estimation. 3 at $19.98 plus 2 at $3.48. So remember, we're estimating. So let's round this to $20. So we have 3 items at $20, and 3 times 20 would be $60, because we're just estimating, right? And then over here, $3.48, we could go ahead and make that $4. Okay, it's closer to $4 than it is to like $3.50. So if we're going to do a good estimate, let's just make it $4. So 2 at $4 would be $8. Okay, and 60 plus 8 would be $68. And the last one is the fun one. 25 times 3 is 75, plus 6 is 81. Square root that, we get 9. Square root that, we get 3. 3 times 9 is 27. Take away 2 is 25. Square root that is 5. Times 9 is 45. Plus 4 is 49. Square root that, and we get 7. That is fun. Okay, so here we're working on our new concept, which is all about similar and congruent polygons. Recall that two figures are similar if they have the same shape, even though they may vary in size. In the illustration below, triangles A, B, and C are similar. Okay, similar meaning they have the same shape. To see this, we can imagine dilating triangle B. Dilating would mean making it bigger. Okay, dilating triangle B as though we were looking through a magnifying glass. By enlarging triangle B, we could make it the same size as triangle A, or we could make it the same size, a little bit bigger, as triangle C. Likewise, we could reduce or make it smaller. Triangle C could reduce to B. Triangle C could reduce to A. Triangle D is not similar. It has an entirely different shape. Reducing or enlarging triangle D will not change. It will not make it look like any of these, right? It will change its size, but not its shape. So now this whole lesson is about learning the rules for congruent and similar triangles and learning what properties each one of those has. So it says, recall that figures that are the same shape and size are not only similar but congruent. Okay, so when we're looking at it, congruent is same shape and size. All three of the triangles below are similar, but only triangles A, B, C, and D, E, F are congruent. So these two are congruent. What they're saying is that these two are similar, meaning they have the same shape. Okay, now figures may be reflected or rotated without affecting their similarity. So what they're saying here is this one being in this position, since these two are the same, DEF is also similar to GHI, even though GHI is in the wrong position to look like it is similar to DEF. So position has nothing to do with similarity or being congruent. When inspecting polygons to determine whether they are similar or congruent, we compare their corresponding parts. Referring back to the illustration of ABC and DEF, we identify the following corresponding parts. So here, when we're talking about corresponding parts, angle A corresponds to angle D. That means angle A and angle D are exactly the same size. Okay, angle B corresponds to angle E. So angle B corresponds to angle E. Now, you're going to see in the next slide how we use hack marks to show similarity. And angle C, so we could make this 3 hack marks, is corresponding to angle F. So we'll make this one have 3 hack marks as well. Okay, and corresponding sides. Now, corresponding sides, when they are congruent, means those sides would be the same size, length. But if we're talking about similarity, corresponding sides would mean that the sides were proportional. Okay, so we have AB corresponds to DE. So let's get a different color here. AB corresponds to DE, while BC corresponds to EF, and CA corresponds to FD. Notice that the order is important when we're doing that. We use tick marks. Sometimes I call them hack marks, whichever. We use tick marks on corresponding side lengths that have equal length and arcs on corresponding angles that have the same length. So here we have A has 2 little measures that are showing the arc here, and 2 little measures that are showing the arc there, showing that those 2 angles are the same. Okay, so here we have a tick mark and a tick mark, showing that these 2, since they both have 1 tick mark, are the same. This has 3 tick marks, and this one over here has 3 tick marks, so they are the same. The symbol, this little squiggly line, represents similarity, and since ABC is similar to GHI, so they're saying these 2 are similar, they're not the same size, but you can see how this one has 3 little arcs, and this one has 3 little arcs, and this one has 2 little arcs, and this one has 2 little arcs, and this one has 1 little arc, and this one has 1 little arc. So They are similar. They're just not the same size. This one over here is a little bit bigger than this one over here. Okay, since A, B, C, and D, E, F are congruent, so these two right here are congruent, then we will use the congruent symbol between them. Now, one thing that's very important is that we always use this triangle ABC has got to be in a certain order that's going to correspond to GHI. So that when I look at it, A will be the same measure as G, B will be the same measure as H, and C will be the same measure as I. It's very important that we get them in the right order. Okay, so notice that when we write a statement about the similarity or congruence of two polygons, we name the letters of the corresponding vertices in the same order. Below, we define similar and congruent polygons in a way that enables us to draw conclusions about their side lengths and angle measures. Similar polygons have corresponding angles which are the same measure, and corresponding sides which are proportional in length. Okay, congruent polygons, congruent as opposed to similar, have corresponding angles which are the same measure. That's the same thing we just read up here. And corresponding sides which are the same length. So congruent polygons are exactly the same size, same angles, and same side lengths. Okay, so here we have which two quadrilaterals are similar. Okay, so to be similar, we have to have the same angles. Okay, so here we have 180, 180, 180, 180, 180, 180, 100, 100. Okay, so this one has not got the same configuration of angles as the other ones do. Okay, now the sides must be proportional. So let's get a marker here and let's say, okay, that means that first of all, I need to make sure when I'm comparing them that I'm comparing them in the same configuration. 180, 180, 180, 180. So, I mean 80, 100. So we're ready to compare these two. They're in the right configuration. This one, however, notice that's 100, but that's only 80. So left to right, 100 to 80, this says 80 to 100. So I need to flip this thing around. So we're going to flip it before we compare it. We're going to put it this way. Okay, so that the 100 is here, and the 80 is here, and the 100 is there, and the 80 is here. Okay, so what I'm doing is I'm taking polygon C and I'm flipping it around. So now let's make the side lengths correspond. So between 80 and 100 here on the short side is 4. And on the long side, it's 6. Short side is 4, long side is 6. Now we're ready to compare our quadrilaterals. Okay, we already marked off this one on the end because it did not have the right angle requirement. So now we've got everything in the same configuration. So we have 12 to 8, which would simplify, if we divide this by 4 and divide this by 4, we would have 3 to 2. Okay, top to side is 3 to 2. Now this one would be divide by 2, divide by 2, we'd get 4 to 3. This one is 4 to 3, top to side. Oops, 4 to 3 and 3 to 2 is not the same fraction. We could cross multiply, and this way we get 9, and this way we get 8. So we know that this one is not similar to this one over here. Okay, so now let's look at the third one here, the C. And this one is C redone over here, isn't it? Okay, so we're going to say 6 to 4. 6 to 4 Divide by 2 on the top and the bottom is 3 to 2. Okay, and we had one other one that had a 3 to 2. 3 to 2 was A, and 3 to 2 was C. So A and C have the same angles, and they have the same proportionate sides to each other. Okay, so polygons are similar if they have corresponding angles are congruent and corresponding sides are proportional. All 4 quadrilaterals have 2 100 angles and 2 80 angles. But we had to nix D because it did not match the same configuration as the others. Figures A and B have the same orientation, so it is clear that their corresponding angles are congruent. We could turn figure C so that it has the same orientation as figures A and B, and see that its corresponding angles are also congruent, which is what we just did when we turned this one right here. There's the original C. We turned it sideways so that we would get 180, 180, 180. So we could see that the angles were all the same. Okay, so we did turn figure C so that we could see the orientation of the angles. And the sequence of angles in figure D does not match the corresponding angles of the other figures, and so we removed figure D from consideration. We crossed it out entirely, didn't we? Okay, so now we consider the side lengths to see if corresponding sides have proportional lengths. Now notice they did shorter to longer. When I did mine, I did longer to shorter. I did the cross the top, which was the longer, to the shorter. I made this longer to shorter. So mine is going to be exactly flipped of theirs. Okay, so notice I had 12/8, which was 3/2. I had 8/6, which was 4/3, and I had 6/4, which was 3/2. And then we decided A and C both had 3/2. So theirs are going to be the flip of mine. They had 8/12 instead of 12/8, and 6/8 instead of 8/6, and they had 4/6 instead of 6/4. So we can see that 8/12 and 4/6 are equal ratios. This one and this one are equal. Okay, and how do we know? They both simplify to 2/3. This is 2/3. This is 2/3. Or we could cross multiply. 8 times 6 is 48. 4 times 12 is 48. And when the cross products equal like that, then we know that they are proportional. Okay, so figures A and C are similar. The ratio of side lengths of figure B does not reduce to 2/3, so it is not similar. Okay, the relationship between the sides and the angles of a triangle is such that the lengths of the sides determine the size and the position of the angles. For example, with 3 straws of different lengths, we can form one and only one shape of a triangle. 3 other straws of twice the length would form a similar triangle with angles of the same measure. Knowing that 2 triangles have proportional corresponding side lengths is enough to determine that they are similar. So here, if 2 triangles have proportional corresponding side lengths, then the triangles are similar. And we know that because of that, the corresponding angles will be equal to each other, or in this case, congruent. We'll put the little congruent side. The corresponding angles would be congruent. So here we are given that ABC is similar to DEF. Okay, A, B, C, D, E, F. Remember, the order that we write it in is important. Okay, so since that is so, we know that these proportions should be the same. So 4 is to 8. 4 is to 8, as 8 is to 16. 8 is to 16. We should always be able to do this. Now, 4 times 16 is 64. 8 times 8 is 64. Besides that, they both simplify to 1/2, don't they? Okay, so we can see that they are proportional. Because they are similar, that means that C must equal F, and angle A must be the same measure as angle D, and angle B must be the same measure as angle E. They must be. All right, so consider the three triangles below. They have corresponding angles with equal measures. Okay, so we have 60, 120, 60, 120, 60, 120. Okay, so these are all the same measures of the angles. How can we determine whether or not these triangles are similar? Okay, so here they all have the same angles in the same order, don't they? If that's true, let's look at this. Okay, so basically we might take the conjecture that the triangles are similar and that any triangle with the same angle measures would be similar to these. We will accept this basic assumption about similar triangles. All triangles with the same set of angle measures are similar. Thus, knowing that two triangles have congruent corresponding angles is sufficient information to conclude that the triangles are similar. This is called angle, angle, angle similarity. If the angles of one triangle are congruent to the angles of another triangle, then the triangles are similar and their corresponding side lengths are proportional. All right, so here we are. Is the perimeter of the triangle on the right 3 times the perimeter of the triangle on the left? Is the area 3 times as great? Okay, so now we're trying to figure this out. First of all, when we look, we have 15 is 3 times 5. X is going to be 3 times 3. 12 is 3 times 4. Remember I told you there was a scale factor, times 3, therefore times 3. So this other side length, X must be 9. Okay, now let's talk about area. Remember, area is 1/2 base times height. Well, 4 times 3 is 12. So 1/2 of 12 is 6. So this area in here is 6 square inches. Okay, now let's look at this one. 1/2 base times height. Okay, so 12 times 9 is 108. But in case that's difficult, 12 divided by 2 is 6. 6 times 9 is 54. Okay, now, we knew that the side lengths were times 3, but look at this. 6 times 3 is not 54. 6 times 3 squared is 9. Okay, 6 times 9 is 54. So whenever we're trying to get from a smaller triangle to the larger triangle or vice versa, it's going to be the scale factor, which was 3 here, squared, that we're going to multiply by. Okay, so here it says we picked 2 sides from the right triangle to write a ratio. So they went left triangle to right triangle. 4 times 3 is 12, therefore 3 times 3 is 9. And the missing side must be 9, which is what they did here. Now, it says the constant factor that relates the ratios of similar triangles is called a scale factor. In this case, the scale factor is 3. Since 3 times 3 is 9, we find that the side of the triangle is 9 inches. An architect makes a scale drawing of a building. If 1 inch on the drawing represents 4 feet, so here's 1 inch.
Aldridge, Julie.
Okay, so we have 1 inch on the scale drawing, and then we have 4, we'll just make this 4 feet. So every little inch on the scale drawing is 4 feet. So if we were If we're going to just keep it inches and feet, that's fine. We multiply by 4 and change it from inches to feet. But that's really a scale factor. Remember, each one of these, there's 12 inches in a foot. So we're really multiplying by a scale factor of 48 to get from here to here. But it's fine if you just say every inch is 4 feet. So 1 inch on the drawing is 4 feet. Then what is the scale factor from the drawing to the actual building? So we're going to say the scale factor is 48 because we're going from inches to 4 feet. What is the length and the width of a room that is 5 inches by 4 inches on the drawing? So 5 inches, since we're going to feet, 5 times 4 is 20 feet, and 4 times 4 is 16 feet. So we're talking about a 20 by 16 foot room. Okay, so on this one, here's the answer. So they're showing you that the scale factor is 48 and that the length of the room is 20 feet by 16 feet. All right, so now it says refer to the following figures in problems A through E. Which triangle is congruent to ABC? So here's our model here, and we're looking for congruent to ABC. So when we're looking, we don't have any of the measures. We're going to look specifically at which one seems to be the same size, okay? So the same size and the same shape. Now this one seems the same shape. This one seems the same size and same shape. So this one would be the one that's congruent. This one looks a little bit too big, doesn't it? This one doesn't look right at all. Okay, which triangle is similar but not congruent to XYZ? So here's XYZ. This one we said was congruent, so this one is the one that's similar. Okay, so I guess we better write these down. So, and remember, we have to write them in the right order. So XYZ is similar to QRP. So we're going to put QRP because we have to put the corresponding sides together. Let's go back and do this one. Which one is congruent to ABC? ABC is congruent to this one, Z, Y, X. Z, Y, X. And that's a triangle in the front. Which triangle is not similar to PQR? Well, PQR is not similar to this one over here. Okay, now, since they're not similar, it doesn't matter which order we write these in. Okay, so we could just say JLK. It does not matter because they are not corresponding sides. We can write those in any order we want to because they are not corresponding, not similar. Which angle in ZYX, ZYX, corresponds to angle A in ABC? So angle A is here, and that one corresponds to Z right here. So we're going to say angle Z. Which side of triangle PRQ corresponds to side XY? So here is side XY. Oops. Side XY. And PRQ, the one that corresponds, would be this one right here. So we would say, and to XY, so we have to even do it in the right order. XY would be the same as QR. QR. All right, so let's see how we did here. And then the last one, F. Oh, they didn't give us the answers to those. That's okay. I just did. Are these two triangles similar? How do you know? All right, so here we have, we don't have any angle measures. They look similar, but let's say 5 is to 6 as 12 is to 15. Okay, so let's cross multiply here. If we 5 times 15 is 75. And 12 times 6 is 72. 75 does not equal 72, so we would say no. Okay, now if we want to, we could do it another way. 5 is to 3. 5 is to 3. As 12 is to 6. Uh-oh, 12 is to 6. That's 2. Right? That's 2. And 5 divided by 3 is not 2. So that just confirms that no, they are not similar. These quadrilaterals are similar. Find the missing side length. What is the scale factor from smaller figure to larger figure? Okay, 3 multiplies by what to give you 9? The scale factor is 3. Okay, so we have a missing side right there. It should be 4 times 3 is 12. For H through J, draw 2 rectangles, one 2 centimeters by 1 centimeter and the other 4 centimeters by 2 centimeters. Then answer the following questions. Okay, so we're doing rectangles. Let's do 2 centimeters by 1 centimeter. So that's a 1, and that's a 2. And then we're going to do 4 centimeters by 2 centimeters. Okay, pretend that's pretty exact. We can pretend, right? So 4 by 2. What is the scale factor from smaller to larger? 2 times 2 is 4. 1 times 2 is 2. The scale factor is 2. The perimeter of the larger rectangle is how many times the perimeter of the smaller rectangle? Okay, well, we know that this is a 1 and this is a 2. So the perimeter of the smaller is 4 plus 2. 2 times 2 is 4. 1 times, so 1 plus 1 is 2. So we've got 4 plus 2 is 6. The perimeter of the larger, 4 plus 2 is 6. Another 4 plus 2 is 6, and that's 12. And isn't times 2 the scale factor? 6 times 2 is 12. So it says how many times more? The perimeter of the larger rectangle is how many times the perimeter of the smaller one? And the answer is 2. Perimeter goes up by a factor of the scale factor. But the area of the larger rectangle is how many times the area of the smaller rectangle. The smaller rectangle is 1 times 2 is 2 square centimeters. The area, 4 times 2, is 8 square centimeters. Okay, remember back, where was it that we said it goes up by square the square factor, scale factor. So we have 2 squared is 4. So we're going to say 4 times larger. We take the scale factor and we square it. So 2 times 4 is 8. So this is how many times you have to multiply the smaller area to get the larger area. Okay, on a scale drawing of a house, 1 inch represents 8 feet. So 1 inch represents 8 feet. Okay, how wide is the garage if it is 2 1/2 inches wide in the drawing? Okay, so we are going to, first of all, what is the scale factor? Remember, we have to multiply by 12 to get from inches to foot. And then 12 times 8 is 96. Okay, so the real scale factor is 96. Okay, but we're not putting this in inches. We're putting this in feet. So it's okay if we just say, okay, we're going to multiply by 8 and then change the inches to feet. 2 1/2 times 8. What is 2 1/2 times 8? Okay, so remember we can do a little distribution here. 2 times 8 is 16. Half times 8 is 4. 16 plus 4 is 20. But it's not 20 inches, is it? It's 20 feet because we multiply by 8 and then change the inches to feet. And that's the same thing as multiplying by inches and then converting it back. Mr. Connors drives his car 11 miles each day to and from work. Is the distance Mr. Connors drives commuting to work proportional to the number of days he works? How do you know? Okay, so he drives 11 miles each day. Okay, and it says, is it proportional? You're going to multiply the number of miles that he drives by the number of days he works. So you would say the number of miles is, there's a scale factor, isn't it? You're going to say the number of miles that he drives is going to be proportional to the number of days he works, because he drives 11 miles every day. So if he drove 11 miles in one day, then we could expect him to drive 22 miles in 2 days and 33 miles in 3 days. And those would all simplify to 11 over 1, wouldn't they? So yes, it is proportional. Okay, and if we cross multiplied, we'd get 22 and 22, right? If a number cube is rolled, what is the probability of rolling a prime number? Okay, well, let's think about this. Let's write out the sample space. We could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6 on a number cube. Now let's think, which ones are prime? Remember, 1 is neither prime nor composite. Okay, 2 is prime. 3 is prime. 4 is composite. 5 is prime. 6 is composite. Okay, so we only have 3 prime numbers out of 6 options. So we're going to say the probability is 1/2 or 0.5 or 50%. Okay, that's the probability. Okay, Adam worked 8 hours per week before his workload was increased. After the increase, he worked 4 hours per day for 6 days each week. How many more hours per week did he work after the increase than he worked before the increase? Okay, so he worked 8 hours per week. Okay, per week, per 1 week, before his workload was increased. After the increase, he worked 4 hours per day for 6 days per week. Okay, how many more hours per week did he work after the increase? So let's think about 4 hours per day for 1 day and 6 days per week. Remember, the days is going to cancel days. We multiply, 4 times 6 is 24 hours each week. Now, he's working quite a few more hours a week, isn't he? He started at 8 hours a week, and now he's working 24 hours a week. And how many more? 24 take away 8 is 16 hours per week increase. Okay, so that's the answer to that one. Number 4, 100 residents of the city were randomly selected for a survey regarding the new gymnasium design. 32 residents approved of Design A, and 85 residents approved of Design B. Use these experimental results to calculate the probability that any city resident selected at random would approve of Design A. Then recalculate the probability for Design B. Based on the results of the survey, which design would you recommend? Okay, so basically 32 approved of A and 85 approved of B out of 100 residents of the city. Okay, so now it says they were randomly selected. 32 residents approved of A and 85 residents. Now, some of them approved of both, didn't they? Because 32 approved of A and 32 plus 85 is more than 100 residents.
Aldridge, Julie.
Let me mark this off. Okay, so out of 100 residents, 32 out of 100, so that would be 32%, would vote for design A, and 85 out of 100 would vote for design B. Okay, so that's 85% would vote for design B. Now, which one would you think is the best design? Most likely, I would go with design B because it has a higher probability of winning everybody's vote. Okay. Now expand and then collect like terms. So expand means we're going to multiply the 3 times the x and the 3 times the 2. So we're going to get 3x plus 6 plus x plus 2. Okay, 3x plus x is 4x plus 6 plus 2 is 8. And that is the answer to number 5. Plot these points on a coordinate plane and then draw segments from point to point to form a triangle. Okay, so here's a coordinate plane, just an XY grid. 0, 0 would be about there, right in the origin there. 4, 0, we'll put it right there. 0, 3, maybe about there. Okay, so now it says use the Pythagorean theorem to find the length of the hypotenuse. So remember, we're doing a triangle. Okay, so this one was 3 steps. This one was 4 steps. And remember, our special triangle 3, 4, 5 is our very famous Pythagorean triple. Okay, but let's do it with the Pythagorean theorem. 3 squared plus 4 squared equals hypotenuse squared. Well, 3 squared is 9, and 4 squared is 16, and together they add to 25, which is the hypotenuse squared. So if the... All right. So h squared is equal to 25. And I take the square root of both sides and I get h is 5. So the hypotenuse is 5 by the Pythagorean theorem, but we already knew that because it's our most famous Pythagorean triple. The last one says find the area and the perimeter of the triangle. Okay, so 6, 8, 10. How do I know that? Because it's a right triangle. And if I simplify, if I divide by 2, I get a 3. If I divide by 2, I get a 4. And if I divide by 2, I get the other side of a 3, 4, 5. And that would be a 5. Okay, so I know it's a 6, 8, 10 is my Pythagorean triple. I could also find that with my a squared plus b squared equals c squared. All right, so now the since I've done that, the perimeter is 10 plus 8 plus 6. 14 plus 10 is 24. 24 centimeters is the perimeter. The area is going to be, because it's a triangle, it's 1/2 base times height. The base is 6, the height is 8, so 6 times 8 is 48. 1/2 of 48 is 24. But this is area, so it's centimeters squared. And we are done with the lesson. Okay, so it's time for you to go do all the homework. This is Mrs. A, and may God bless you. Oh, before I go away, I forgot to finish number 6. And I went back and everything is right, but we forgot to answer the questions. I forgot to do that. So it says, what is the perimeter? Well, perimeter is just adding the 3 and the 4 and the 5 together. 3 plus 4 is 7, plus 5. 3 plus 4 is 7, plus 5 is 12. So 12 Units, so we'll just say units because we don't know what its measure is. And then the area of a triangle is 1/2 base, which we can say is 4, times height, which we'll say is 3, and that's 1/2 of 4 times 3 is 12. 1/2 of 12 is 6, but that is area, so that will be square units. And now we are really done, and all of your work is correct. I just forgot to finish that last one. See y'all later.